First example we are going to look at is y dt plus 4y is equal to exponential of minus t, where y is the dependent variable and t is the single independent variable. So we have to define our variable as a symbolic variable using sims. So sims, so I have y and it depends on t. So the second thing is to define our ordinary differential equation. So ODE will just be equal to, so we have dy dt. So in order to define any derivative of first degree, second degree up to n degree, you can use div and you put the dependent variable, then the independent variable, then the degree, which is 1. But for first degree, you can just leave it as div y, and by default MATLAB will know you mean the first degree. So I will also have plus 4 times y, and then is equal to exponential of minus t. So this is my ODE. So now the solution, you can find the solution. Let me just call it y solution sol n using the dissolve function. So you can find the solution using the dissolve function, and you can give it two critical arguments. So the first one is the ordinary differential equation, while the second argument is the condition. So if you only give it the ordinary differential equation, the answer will turn out to have unknown constants, and you have to have like predefined conditions in order to know the unknown constants. So let us see the solution with unknown constants. So if I run this one, you can see my y sol n in the command window, and it is exponential of minus t over 3 plus c1, which is an unknown constant, times exponential of minus 40. So if I want to find c1, I have to define a condition, and the condition I have is the value of y at 0 is just 1. So now I can just give the second argument as my condition. So if I run it again now with the condition, you can see I have my c1 now computed as 2 over 3. So that is the first example. And the second example we are going to look at is, so the square y dt squared is equal to cos 2t minus y. So I also define my symbolic variable y of t, and now let me define my first derivative dy as div of y t and 2, since it is second derivative, the first derivative, or I can leave it, yeah, so this one is the first derivative dy. So let me define my ODE. So my ODE will be, I have the square y over dt squared, so it will be div of y comma t comma y comma t comma 2, then is equal to cos 2 times t, then minus y. So I will go ahead and find my solution. Let me call it y solve is equal to dissolve. So without any condition, I would expect it to have some unknown constants. So if I run it, as you can see, I have unknown constants c1 and c2, and this one is a relatively long solution. So if it is a long solution, you can check if there is a simplification of the solution using the simplify function. So I can just have y solve is equal to simplify, then my previous y solve. So if I do that, MATLAB will check to see if there is any simplification of this solution. So as you can see, now it is a bit reduced, so it is a bit simplified, but I still have my unknown constants C1 and C2. So how can I find them? So for a second degree ordinary differential equation, I have to have two conditions in order to find my C1 and C2, and the conditions are, the first condition is the value, I will have my value of y at 0, I'll define it as 1, and condition 2 will be the value of y prime at 0, and I will also call it 1. So this one will be double equality sign. So my condition will be in vector form now. So I will have condition 1 and then condition 2. So all I need to do is to come here and put in my condition. So I can then run to see. So as you can see, I have my value for C1 and C2 here without any unknown constant, and that is my solution for the second ordinary differential equation. So if you like the video, please like and subscribe to the channel, and if you want to learn how to solve other equations in MATLAB, kindly watch the playlist on the screen. Thank you.